As we continue our discussion about quadratic functions, we've already talked about vertex form, so now let's look at quadratic functions in standard form. Standard form says f of x is equal to ax squared plus bx plus c. And now we have to pick out those same characteristics that we pulled out of vertex form, but when it's written in this form. So the first thing we talk about is that a, that number in front, which looks awful familiar. If it's positive, it opens up. If it's negative, it opens down. So that's still consistent with what we did in vertex form. The axis of symmetry is still x equals, but now we have to get it out of this form. So we do the opposite of b divided by 2a, and that will give me my axis of symmetry. Now, the nice thing about that number is that number gets repeated here in the vertex. So that's something that's similar to when we did vertex form. We had the vertex and the axis of symmetry came right from the vertex. Here we actually calculated the axis of symmetry first, and that helps us fill in that vertex. Now, this might seem a little confusing, but all this second part is saying is take whatever you got for x and plug it back in to this function here and here, and you'll figure out the y portion. So that's how we get the other half of our vertex. And our y-intercept is probably the easiest one because the y-intercept is just whatever number is sitting down here, 0, c. So let's dive into an example and see if this makes a little more sense. Here's a standard form quadratic, y equals 2x squared plus 8x minus 2. And we're going to pick out these pieces that we need, just like we did with vertex form. So the first calculation I want to do is this one. Opposite of b, so negative 8 over 2a. A is also 2, so I get negative 8 over 4, which is negative 2. So I now know the axis of symmetry is negative 2, and I also know that the vertex, half of it, is negative 2. Now if I take this negative 2 and plug it back in, y is equal to 2 times x squared plus 8 times x minus 2. I'm just plugging my x answer back into the original function. So here I have 8 minus 16 minus 2. So I get a negative 10. Now that I have my vertex, I have my axis of symmetry, I know that this is positive, so it opens up. We have a minimum value, so y equals negative 10 is my minimum. And my range then would be all the y's greater than or equal to negative 10. Now, of course, if you are a visual type of learner, you can certainly graph this, find these same things on a visual graph, but it looks something like this. Negative 2, negative 10. The y-intercept, I didn't put that up here, the y-intercept is negative 2. This thing opens up. It looks something like that. But you have lots of resources where you could graph that. I'm going to add the y-intercept on here. 0, negative 2. I just pull it right out of there. Let's take a look at another example. Now, right away, I notice that this one is pointing down. So we're going to have maximums, and the range is going to be everything less than or equal to something. I got that right away. The y-intercept is the easy one. This thing crosses at 0, 3. I just pull that out of the standard form. Start with my first calculation. My first calculation, x is equal to the opposite of b over 2 times a. So in this case, I have a negative 6 over a negative 2. X is 3. I'm going to put that in here. Now I'm going to plug my 3 back into my original equation. So y equals negative 3 squared, 6 times 3. So I get a negative 9, a plus 18, and a plus 3. So negative 9 plus 18 is 9, 9 plus 3 is 12. So I now know the maximum is at 12, and y has to be less than or equal to 12. So really only two calculations, x and y, to get that vertex, and everything kind of follows just like the vertex form. Now that we have two different forms of writing quadratics, we have to learn how to convert between the two different forms. So let's start with something that's in standard form. That's the form we've been talking about today. Standard form, here's my A, here's my B, and here's my C. Sometimes it helps people to mark those before going into this. Now, if I want to put it into vertex form, I need to know the vertex. I'm going to go back to that first calculation, x equals opposite of b over 2a, and figure out what x is, because I need that for vertex form. So opposite of 10 over 2 times 2, looks like I get negative 10 over 4, which is negative 5 halves, so there's my x. Opposite of b over 2a. Now I'm going to take that negative 5 halves and plug that in for x to figure out my y. My y is equal to 2 times negative 5 halves squared, 10 times negative 5 halves, plus 7. So I might end up with a fraction, that's okay. Here, this calculation gives me negative 25. Here I get 25 fourths, but I'm going to get rid of that 2, so I get 25 halves. It's going to be positive, so I have a little bit of calculation. Here I get 18, so I get 25 halves minus 36 halves, 9 halves. Doesn't matter that it's fractions. I just needed to figure out x and y. So now I can take this and I can go my h coordinate of my vertex, my x coordinate was negative 5 halves. Remember, I switched the sign going in. My y coordinate, my k, I ended up with 9 halves. And sometimes people panic. They think they have to do another calculation for A. A is sitting right here. It's the same A. So there it is in vertex form. All I needed was h and k, the vertex. Now, conversely, if they give me something in vertex form and say put it into standard form, the calculations are a little different. Some algebra skills here. First, I'm going to square this out. Some of us FOIL, some of us box, however you do this, but you end up with an x squared minus 2x plus a 1 and a negative 3 that needs to be distributed in. So I get a negative 3x squared plus a 6x minus a 3. And I'm going to combine like terms here. That gives me a plus 5. There's my A, there's my B, and there's my C, putting it into standard form.